Again, we already went over this together. Atom is a single building block of matter, matter being everything in our universe, right? So everything that's physical in our universe that has mass and volume, right? So mass is everything physical, okay? Elements, on the other hand, are made up of several of the same type of atom. So taking a look here, we can often use these pretty interchangeably. We might say the hydrogen element or the hydrogen atom, but again, technically, hydrogen atom. Technically, the hydrogen element is many of the same type of atom, many of the hydrogen atoms, whereas a hydrogen atom is just talking about a single atom. Go ahead, give me a smiley face or emoji in the chat box if that makes sense. All right. Smiley faces, emojis. Excellent, excellent. All right, so I'm going to go ahead and send out the notes in the chat box. Once you have your notes open, go ahead and start raising your hands, because you know I'm going to ask for 100% of you to raise your hands in just a few moments. Awesome, good, Eva. And make sure to try both links. If one doesn't work, just try the other link, or you can always go to your grades tab. Raise your hands, raise your hands. Remember that the reason we need our notes open during class is because if we do our notes outside of class, remember you only get notes credit. Whereas if you do your notes during class, then you actually get both notes and attendance credit, right? That's the only way that we track attendance, besides the fact that we know that you're here, right? So you have to be here and do the notes. So that's why we want your notes open right now. All right, looking good. All right, let's go ahead and keep on moving here. This is a reminder, please do not share contact info. Please make sure to participate often and well and behave appropriately. Don't forget that these are being recorded for learning purposes that are listed here. We are on day 10 out of 60, so we are officially a sixth of the way through our trimester. It's going by quick, and we have spring break next week. Awesome. Smiley faces or emojis or yeses in the chat if you're excited for spring break. I know your teachers are. Yes, Alexis, Genesis, Rosa. Exactly. So this week, we're going to be taking a look, continuing talking about the atom. Again, that single building block of matter. We need to really go in depth with the atom because chemistry is all about atoms. So today, in particular, we'll be taking a look at atomic number and mass. So this is a reminder that on Thursday, your Unit 1 food project was due. Remember, it is worth over 70% of your grade. You can see that right here. So extremely important that you get that done. It's impossible to pass the class if you don't do your projects. Oh, good. Yeah, I'm excited to chill out too. Yes. Don't forget that we do grade the projects on a 5 through 10 scale, which is to your advantage, as long as you provide a valid attempt. Remember, the word valid means that there should be no blanks, no random answers. It should be extremely clear that you watched the recording. The recording goes over every step, every slide, and has a lot of the answers. So if I give you an answer in the recording, I should see that answer in the slides. Otherwise, I know that you didn't watch the recording. So watch the recordings, please. That is considered a valid attempt. The lowest grade in that case would be a 50%. Remember, the whole point of this grade scale is we don't want to penalize you for things that you don't know. We want to celebrate all the things that you have been learning and what you do know. So that's why we grade on this scale. So don't be intimidated by the projects. Again, the main idea here is you just have to try your best. And those will be zeroed out today. You can still submit them even after they're zeroed out and still get full credit. But again, you will see your grade drop if you haven't yet turned it in. Don't forget, we also have office hours most Tuesdays and Thursdays at 2 p.m. So if you do want help, you can always come to office hours. It's a short project, so we can knock it out of the park in about 30 minutes. So definitely come to office hours if you need help. Yes, just try, Alexis. Exactly. All right, let's go ahead and take a look here. We are taking a look at reviewing protons, neutrons, and electrons, how atomic number and mass are defined, how we find the number of protons based on atomic number, and how to calculate atomic mass. Oh, cool. That's awesome, Eva. All right, go ahead and open up your notes again. Here is the link to my students. Here's the link to Mr. Bangle's students. Again, if one link doesn't work, try the other one, or just go straight to it from your grades tab. It's also in your announcements, your class plan, your content tab, and your... Wait, that's everything. Yeah, go ahead and raise your hands. I'll give you 20 more seconds to raise your hands. I do need 100% participation.
Last week, let's talk about protons, neutrons, and electrons. Get out your whiteboard tools. Use your thin lines to match the appropriate term with its definition. Remember, we have our three subatomic particles being protons, neutrons, and electrons. They each have their own charge, their purpose inside the atom, and their location on the atom as well as mass. All right, so protons think pro, neutrons think neutr. Those are the beginning parts of the words that describe their charge. And then electron, think about how they act as hands that grab onto other hands. Confirm what we already probably know. So yes, protons are determining the identity of the atom. So one element will have a different amount of protons versus another element. They are positively charged and they are in the nucleus with a mass of 1 AMU. Remember, AMU standing for atomic mass unit. Neutrons are similar. They prevent repelling in the nucleus, right? So those same charges, they prevent the protons from pushing away from each other and having the atom fall apart. They are neutrally charged. So again, that keyword being neutron, neutrally charged. They are inside the nucleus with a mass of also 1 AMU, just like the proton. Then finally, the odd one out here seems to be the electron, but they also have the very important job of being involved in bonding. So that's kind of like when you want to bond with someone, you hold hands with them, and they are negatively charged while orbiting around the nucleus, and they are not inside the nucleus, right? While having very little to no mass. All right, so go ahead and raise your hands like a lot of you have already done to indicate that you are done and ready to move on from number 2.
Cool. All right, let's go ahead and take a look here. So protons, again, taking a look at the prefix here, pro, like pros and cons. Pros are the good ones, and so they have what type of charge? Pros are the good ones, so they have what type of charge? Tell me in the chat. Yes, Jordan. Yes, Paul. Creek. Yes, Eva. Yes, these ones are positive. Excellent. Now, on the other hand, taking a look here, neutrons. Oh, sorry. Actually, let me talk a little bit about protons. So protons are the atom's identity. They are in charge of the identity of the atom. If protons were to change, it would no longer be the same type of atom. We, on the periodic table of elements, we identify the number of protons based on its atomic number. So atomic number we're going to be taking a look at closely in this unit, in this lesson. Atomic number is the same as the number of protons. Now, protons are found in the nucleus. Anything in the nucleus has mass, and so these ones should weigh how many AMUs? Anything in our nucleus has mass, and so they should weigh how many AMUs? Thank you, Tara. Get some more answers in the chat. Yes, yes, yes. Thank you, Rosa. Using units. Yeah, it should weigh 1 AMU. Perfect. Neutrons, again, have that first 5 letters right here, neutral. And so they literally sound like the word neutral. Tell me in the chat, neutral, does that mean positive 1, 0, or negative 1? What does the word neutral actually mean? Give me a number. Yeah, it means 0, so they have 0 charge. Perfect. The whole point of neutrons is to prevent repelling in the nucleus. Remember, protons are all positively charged, and like charges actually don't want to be next to each other. So protons naturally want to repel each other. Neutrons are neutral, though, so they're kind of like buffers, and they help to prevent those protons from repelling. They're kind of like that friend in the group where you have 2 people that often fight with each other, but if that one friend is there, they can act like a buffer, and then those people don't fight in the group, right? So maybe you might be a neutron in your family or in your friend group. Yeah, they prevent beef. They're a stabilizer. I love it. Yeah, so these ones are also in the nucleus, so these ones also weigh 1 AMU. Again, anything in our nucleus has mass. And then finally, electrons we saw just a moment ago have a negative charge. Again, I know that we just went over this, but we're showing you the diagrams just so that you can put those words to the images. They are on the outside of the atom, what we call orbiting, and remember they're like the hands of our atoms. Again, just like real hands on you, your hands are on the outside of your body. They're also very tiny. Electrons are on the outside of an atom and are very tiny, and so they can hold hands with other atoms. Again, that process is called bonding. Now, they are on the outside of the nucleus. They're not in the nucleus, so they actually have negligible mass. Tell me in the chat box, negligible mass is about what number? Negligible is about what number? Negligible. What does negligible mean? No, so negligible means nothing or almost nothing. So let's correct those answers. Yeah, this would mean 0. So this would be about 0 AMUs, almost no mass. Excellent. All right, let's go ahead and talk a little bit about protons and atomic number.
By its number of protons. So we're going to start learning how these numbers of protons affect how an element acts or what an element is. Remember that the number of protons determines this unique identity. So with carbon down here, we can see that carbon is in multiple forms. We can see that it can form a solid diamond. It can be a solid coal, which we can use as fuel. And then when we burn that fuel, it becomes into a gaseous form that we can see coming out of the smokestacks in the middle picture. But however, even if it changes form, the carbon is still having its same amount of protons. Okay, when we look at the periodic table, we can also call its amount of protons its atomic number. So right here, atomic number is the number of protons. Okay, so elements, right, even if you break them down into a simpler substance, right, or I'm sorry, you cannot break down elements into a simpler substance other than the atom, because if you break them down any smaller than that, then you just get the subatomic particles that we discussed last week. All right, so let's move on and discuss why that you cannot cut paper into multiple atoms.
All right, so let's take a look at this. So let's analyze this meme. Have you ever been cutting a piece of paper with scissors and worried that you might cut an atom in half and destroy the world? This person responds, paper does not have atoms, and this person says, I don't want to live on this planet anymore. Courtesy of Futurama right here, yes. All right, let's go ahead and first talk about, there's a couple crazy things going on in this statement. So first off, paper does not have atoms. Is that statement true? Yes or no? Think about how paper is a physical substance, which means it is matter. It's a physical substance, which means it is matter, and all matter is made of atoms. So does paper have atoms? Yes or no? Does paper have atoms? Yes or no? If it's physical and all matter has atoms, yes, it does. So this, first off, is a crazy response. We know paper has atoms, all right? It's a physical substance. All matter has atoms. That's the building block of matter. Yeah. Well, it has atoms have one atom, right? An atom has one atom. Now, the other thing here is that there is partially a true statement here. If we were to be able to kind of split an atom in half, this actually can cause an explosion. And if that explosion is big enough, possibly could destroy the world, or at least parts of the world. This is actually where nuclear bombs come from. Jasmine, if you missed anything, we can go back to it after class. So again, everyone else, please make sure you don't put answers in the chat. If people ever miss anything, we want to actually go back to the slides after class for those people so that they can actually see what they missed. Okay? So these are nuclear bombs, right? Splitting atoms that can result in a really big explosion, all right? But the thing is here that paper and scissors are both made from atoms. So if you were to kind of zoom in and we had a scissors here and we had our paper here, all right, they would both be made of atoms, which on a atomic scale would look pretty big to each other. So in our mind, think of it like a planet trying to cut through half of another planet. That's not going to happen. They're just going to kind of push each other apart from each other, which is how scissors work. The atoms in the scissors push apart the atoms in the paper in order to split it in half, but at no point do you actually cut a single atom in half. Go ahead, give me a smiley face or an emoji in the chat box if that's beginning to make sense. So lots of crazy statements here. We know better now. We've learned better here. Paper is made up of different compounds. So again, paper is not on the periodic table of elements, so it's not an individual element. It's going to be made up of many different elements together, like carbon and oxygen together. Excellent. Oh, thanks, Cecile. All right, let's go ahead and take a look here and talk a little bit about why protons are so important. So remember that a different number of protons results in different elements. Protons are related to identity. So if you change the protons, you change the identity. Example, hydrogen has one proton. If I were to add a proton, it's no longer hydrogen. Now it has two protons. Now it's what we call helium. All right? So these are two different elements, and not only are they different in identity, but they're also different in properties. For example, hydrogen and helium can both float, but one of them can light on fire. Let's go ahead and take a look at a video of this in action. So I'm going to go ahead and pop this up on the screen and share this with you. And what you're going to identify is which of our two balloons here actually lights on fire. So they're both going to pop, but which one lights on fire, blue or red? Here we go.
Helium should not react, and the balloon will just pop. Hydrogen, on the other hand, will react with oxygen. Does not react. The balloon just pops. Overcoming the activation energy, getting the hydrogen inside the balloon to react with the oxygen that's in air. Here we go. Ready?
Yeah, I know he's a little bit hard to hear. So that's all I need you to tell me is in the chat, which one lit on fire, the blue one or the red one? Again, they both popped, but which one had fire? Yeah, the red one. Okay, so here's the deal. His blue one was filled with helium, our 2-proton atom, whereas the red one was filled with hydrogen, our 1-proton atom. And so just a single difference in a proton made a really big difference. Let me go ahead and jump back over to our slides, and we can go ahead and take a look at what I mean by that, because there is a really good but kind of terrible real-life example here, okay? Umeza, try logging out and back in. Yeah, so here's the deal. Great connection, Matt. We're going to talk about that right now. So hydrogen, as mentioned, has 1 proton and is also extremely flammable. Helium, though we just saw, is non-flammable. Now, this is important because in 1937, we had what's called the Hindenburg disaster. The Hindenburg was an airship, all right here. And what you can see is that when the Hindenburg crashed, it actually caught on fire. All right, so this disaster might have already been a bad disaster anyways if it had crashed with helium, but it was made even worse by the fact that it was filled with hydrogen, because at the time, right, we just thought, well, hydrogen floats, let's fill it with hydrogen. But the problem with hydrogen is, again, it's extremely flammable. So not only did this crash, but it also exploded on fire. And so the injuries and the deaths were probably significantly worse than what they would have been if it had been a non-flammable gas like helium. So nowadays, we definitely no longer fill airships or blimps with hydrogen. Instead, airships were then later on filled with helium, right? And this is also important because think about at kids' parties, we fill our balloons with helium. And at kids' party, what do you blow out on the cake? Tell me in the chat. Maybe not anymore because of COVID, but usually, what do we blow out on cakes? Yeah, the candles, and candles have fire. So we definitely don't want to be filling children's balloons with hydrogen, because then you have a bunch of flammable things floating around that cake. Whereas with helium, right, even if it might pop the balloon, it's not going to catch on fire. So the main idea here, the most important thing to understand, is a single proton makes a huge difference. Protons matter for identity. Protons matter for characteristics. This is number 3. Please fill in the blank with the word single, only the word single. Make sure you spell it correctly. You have 20 seconds to raise your hands. Okay, so taking a look here, hydrogen and helium are on the periodic table. And again, we said that protons are probably the most important thing for identity, right? So protons are identity. All right, but they are also actually shown on the periodic table in the form of the atomic number at the top. So it's going to be the whole number, the number without any decimals, at the top of our, generally, it's usually at the top of our square here. So for example, hydrogen always has 1 proton and has an atomic number of 1. Helium always has 2 protons and has an atomic number of 2. Again, taking a look at the number at the top, that's what we're going to be focusing on in the next few slides. Green checks if that makes sense. Again, atomic number, protons always found as the whole number, generally at the top of our squares. All right, beautiful. Let's go ahead and practice this together.
Number 5, we're going to start with number 4 first. It says, using our pointers on the whiteboard, how many protons are in fluorine? We have the atomic square here, the little tile for fluorine as we would see it on the periodic table. But let's take our pointers and let's point to which of these numbers on the tile is the atomic number for fluorine, which tells us how many protons it has. All right, awesome, guys. Looks like we're all hovering around the number 9. Yes, so for fluorine, the answer for number 4 is going to be 9. So atomic number of 9 for number 4. All right. So then for gallium, same instructions. For gallium, what is that atomic number? 31. Very good. So remember, the atomic number is the number of protons for that element. So every atom of gallium is going to have that exact number of protons. Notice that to talk about the atomic number or to point to it, we don't need to know about the name of the element. We just need to know where that number is located on the tile to know that that is the atomic number. So, yeah, exactly, Creek. Yeah, gallium is atomic number 31. So please raise your hands for number 4 and number 5 so we can move on. I'll give everyone about 20 seconds. Yes, we already know the name, but we need to know the atomic number. All right, so for this one, same question, but now you are completing it on your own. How many protons are in this atom of this unknown element? It is unknown because we don't know the name, but one of these two numbers should be the number of protons, right? Or the atomic number. So if you have a question, please post it in the question and answers chat so we can answer it for you and so that we don't give away the answer to the entire class.
All right, so far we've learned some really important stuff here. We have learned that atomic number at the top, right, is related to the number of protons, which again is related to identity, okay? So atomic number found at the top of the square is our number of protons and is in fact our identity of the atom, okay? Now we're going to go ahead and talk about atomic mass though, and atomic mass actually includes both protons and neutrons, everything inside of our nucleus, because remember, everything in our side of our nucleus has mass, specifically protons and neutrons, each weigh 1 AMU, right? So atomic number is only protons, only identity. Atomic mass, though, is actually both protons plus neutrons. Give me a smiley or an emoji in the chat if that's beginning to make sense. Smiley or emoji in the chat if that's beginning to make sense. Excellent. All right, so we're going to go ahead and actually practice this. Keep in mind that when we talk about atomic mass, again, we ignore electrons. Electrons are not in the nucleus. They have negligible or almost no mass. So they are on the outside. We don't care about them. Okay, we only care about the protons and neutrons for atomic mass. They're the only things that actually have a big amount of mass. All right, let's go ahead and talk a little bit about that. So these are what we call isotopes. Isotopes are variations of the same element that have a different atomic mass due to a different number of neutrons. So we can change neutrons, we can change electrons. That will not change the identity of the atom, but it will change other stuff. So neutrons will change mass. Electrons have charge. Electrons can change charge. The only thing that can affect identity, though, is what? Tell me in the chat. Protons, neutrons, or electrons. What is the only thing that affects identity? We just talked about this when we were talking about hydrogen and helium. The only thing that affects identity is, I see Tara in the chat. I see Rosa, Jordan. Yeah, so only protons affect identity. So again, we can change other stuff. So we can change the number of neutrons, which will change the mass, but it's not going to change the identity. That's what's called an isotope. It changes the mass, but not the identity. Let's go over some examples, because I know that's a lot of words, and it's easier when we have an example. So we have an element with 8 protons and 8 neutrons. So first off, I need to find the identity of this element. Again, identity comes from the number of protons, which is 8 protons, and that is from our atomic number at the top. So in the bottom area, in the blue boxes, tell me which of those 6 squares have an atomic number of 8. Atomic number at the top, atomic number or 8 protons at the top. Atomic number of 8, 8 protons at the top. Thank you, Haley. Thank you, Seraphim. Thank you, Rosa, Matt, Sophia. Yeah, it's going to be oxygen. Yeah, so oxygen has an 8 at the top, so we know that this must be oxygen. Anything with 8 protons will always be oxygen. If you change protons, it's no longer oxygen. So 8 protons is always oxygen. Now, mass, though, again, we said comes from protons plus the neutrons. So let's go ahead and take a look at that. 8 protons plus 8 neutrons. What is 8 plus 8? Units should be AMUs for mass, atomic mass units. Don't give me naked numbers. Put some units on them. 8 plus 8 equals what? 8 plus 8 equals what? Alexis, check your math there. There we go. All good, Alexis. 8 plus 8 equals 16. Yes, 16 AMUs. All good. And so what we would call this is we would take the identity of it, oxygen, and the mass of it, and we put those two things together. So the name of this isotope is actually oxygen-16. Okay, go ahead, give me a smiley face, thumbs up, or a yes in the chat if that makes sense. The name of this isotope would be oxygen-16. Again, it would always be oxygen, depending on the number of protons. If it's always 8 protons, always oxygen. But the mass could change, so you could have oxygen-16, 17, 18, 19, so on. All right, this is the answer to number 7. You should have 2 answers selected for number 7, both its identity, which is oxygen, and its mass, which is 16 AMUs. Make sure you select both, otherwise the computer will mark it as wrong. You have 20 seconds to raise those hands. Let's go ahead and try 2 more examples here. So this time we have an element with 8 protons and 10 neutrons. Again, identity comes from what? The protons or the neutrons? P or N? Tell me in the chat. Identity comes from P, protons, or N, neutrons? Yes, it comes from protons. Excellent, Shane. Yes, so right here, again, this is our number of protons. This is therefore also our atomic number at the top. So taking a look down here, which of these has the number 8 at the top? 8 protons, an atomic number of 8. It's actually the same one. I told you anything with 8 protons is always what? Yes, this one is still oxygen, All right. Now this time though, our atomic mass will change because this time we have more neutrons. So now we have 8 protons, still oxygen, but a different mass from extra neutrons. So 8 plus 10 gives me what? What is my new atomic mass? 8 plus 10. Thank you, Sophia. Get those units on there, no naked numbers. Yes, 18 AMUs. And so what would I call this? Take the name, take the identity, take the mass, put them together with a dash in between them. What is the name of this isotope? Again, it's an isotope because it's still the same atom, just with a different mass. How would I name it? Take the identity, put a dash, and its new mass. Identity dash mass, just like we did with our previous one. How would I write this out? Tell me in the chat. Thank you, Matt. First one on it. Let's go. Thank you, Camila. Camila, check that mass. Again, we said it was 18. Excellent. There we go, Camila. Good correction. Get some more answers in the chat. Thank you, Rosa. Yeah, so this one would just be called oxygen-18. You don't actually need to include the units for the name of it, just so you know. I know that's a little confusing. So this one's just called oxygen-18. So this will be the answer to number 8. Again, identity is oxygen because of its 8 protons. Its mass has changed though now. Now its mass is 18 AMUs. 20 seconds to answer number 8. Again, make sure you check off both of those answers. All right, let's go ahead and take a look at this last one. So this last one, we have 15 protons, 16 neutrons. Find the one with the atomic number 15 at the bottom. What is the one with the atomic number of 15? Atomic number at the top. Sorry, when I say at the bottom, I mean the bottom of the slide. Did not mean to confuse you there. Take a look which one has the number 15 at the top of its square. Thank you, Alexis. Thank you, Shane. Thank you, Rosa. Now I want some pho. Delicious. Yes, this one is going to be phosphorus. Its identity must be phosphorus. Anything with 15 protons must always be phosphorus. And its mass, though, can change. So mass is going to be 15 protons, which we must always have. But with this one, it's 16 neutrons. What is 15 plus 16? 15 plus 16. Yes, Tara. Yes, Jasmine. Yes, 31 AMUs. And so our name here would be what? Our name here would be phosphorus what? Phosphorus what? Yep, phosphorus 31. Excellent. This is the answer to number 9. Again, identity is phosphorus. Mass here is 31 AMUs. Tell me in the chat once you submit, how did we do? Raise your hands, and then tell me in the chat, how did you do? A's and B's want to shout you out. Excellent, Alexis, great job. I'm just going to go over these really quick. We talked about protons, neutrons, and electrons. We talked about atomic number and mass today. I'm going to go ahead and skip this and stop our recording. Go ahead and make sure you submit that, and we will see you tomorrow. Thank you so much, everyone. Don't forget to do your project. We will be zeroing out that today, and come to office hours if you need help on Tuesday, Thursday. Bye, everyone. Thank you.